I want to take a look at some comparison tests. Sometimes we have integrals that we want to know whether that they converge or they diverge, and they're kind of hard to do. So if we can compare them to something else, we might be able to make our work a little less. Anyway, here's the situation. Suppose you've got two functions that well, one of them is the integral you want to do, and you're going to compare it to another one. Now I'm writing it as an integral from a to b, but I want to leave open the possibility that maybe a is negative infinity, or maybe b is positive infinity, or that f or g have vertical asymptotes within the interval from a to b. So these are potentially improper integrals. Okay. So suppose also if f of x is always greater than or equal to g of x for x on the interval a to b. Okay, so f is the big function and g is the little function. So here's some things I can say. One, if the integral from a to b of f of x converges, I also want to point out that these are positive functions. I'm dealing with positive functions. So if f of x, the integral of f of x converges, so if this one's finite, then the integral of the smaller function must also be. Then the integral from a to b of g of x dx is also finite. On the other hand, if I know that the integral of the smaller function diverges, so I know that this integral is giving me an infinite value, then the integral of the bigger function must also diverge. Let's give you a couple examples here. We'll do one in each direction. So I want to take a look at the integral of 1 over 1 plus x squared dx from 1 to infinity. Now, it turns out I can actually do this integral, but I want to do it by comparison. In fact, I want to compare it to 1 over x squared. I want to note that 1 plus x squared is always greater than x squared. Right? It's 1 greater than. And so if I take the reciprocal of both of these, that will be less than 1 over x squared. Now I have to be a little careful. Taking reciprocals does change the sign of an inequality as long as both of the numbers are positive or both of the numbers are negative. If you have a negative and a positive, then it doesn't switch the sign. But everything here is x squared has got to be positive, so x squared plus 1 is certainly positive. And when I take a reciprocal, it changes the order, right? Where I have 2 is less than 3, 1/2 is actually greater than 1/3. Taking the reciprocal changes the order of that inequality. So this is the bigger function. The one I have is the smaller function. What I know from a previous video is that 1 over x squared integrated from 1 to infinity is finite. I think it's equal to 1. But it's finite. This integral converges. And this is the bigger function, so the integral of the smaller function must also converge. It's finite as well. Now, I'm actually going to do it just because I can. Notice that the integral from 1 to infinity of 1 over 1 plus x squared dx is the arctan of x evaluated between 1 and infinity. So it's arctan of infinity minus arctan of 1. Arctan of infinity, again, we're not really plugging an infinity in, we're plugging in a big number and we're making it bigger and bigger and bigger. And if you look at the arctan function, it's a sideways tangent function. And as you put in bigger and bigger values, the arctan has a horizontal asymptote of pi over 2. So the arctan of infinity is actually pi over 2. The arctan of 1, the angle whose tangent is 1, is pi over 4. So this is pi over 4. Okay. Finite. Finite. Okay, so now let's try another one. Let's take a look at the integral of, from 1 to infinity, of x plus 1 over the square root of x to the 4th minus x dx. Now this is one that, I don't know, maybe I can integrate it, but it's not immediately obvious to me that I can find an antiderivative. But I'm going to compare it to something. And there's always the question of what are you going to compare it to? And I'm looking at this thing and saying, as x is going to infinity, because that's the problem here, x is headed towards infinity, what is this function looking like? Well, when x is really big, the plus 1 is irrelevant. I mean, if x is 1,000,000, and I'd say 1,000,000 plus 1, well, there's hardly any difference there. Likewise, down here, if x is 1,000,000, then x to the 4th power is ginormous. I mean, it's huge compared to x. So I'm really looking at this thing thinking this looks like an x on the top and it looks like a square root of x to the 4th on the bottom. Well, square root of x to the 4th is just x squared. So this is looking to me like an x over x squared. But x over x squared is just like a 1 over x. And so I'm thinking, this function is probably behaving like a 1 over x. And 1 over x, as you integrate from 1 to infinity, that diverged, right? So I'm expecting this to diverge. And if I'm going to try to show that this diverges, then I have to show that this function, this function here is actually bigger than that one. So let's see if I can do that. The thing that I notice, first of all, is that x is between 1 and infinity. So x is a positive number. And if I look at x to the 4th minus x and compare that to x to the 4th, I'm going to claim that x to the 4th is the bigger number. I hope you'll agree with that. Everything's positive here, so I'm subtracting off something positive from x to the 4th, so that's less. This function is only going to make sense to me if x to the 4th minus x is positive, so I'm still going to assume that this is a positive number here, because if I take the square root of both of these things, then the bigger number is going to have the bigger square root, so the inequality stays the same. Okay. I need to put that in the denominator. So if I take a reciprocal now, if I do 1 over this square root, and I do 1 over that, well, that one's just an x squared, right? So 1 over x squared. Taking a reciprocal of two positive numbers actually changes the inequality around, right? I now want to multiply both sides by x plus 1. If I multiply both sides by x plus 1, no, I don't. I want to multiply both sides by x. So I just want to put an x in the numerator here over the square root of x to the 4th minus x. And this is going to be an x over x squared. I claim that that inequality stays the same because I multiply both sides by a positive number, right? X is between 1 and infinity. X is between 1 and infinity, and so it's positive. So I multiply by a positive number. That's good. This one right here is just equal to 1 over x. And then here's a little bit of shenanigans you can do with inequalities. I'm going to add 1 to that x to that numerator. X plus 1 over the square root of x to the 4th minus x. And the thing is, if I make a numerator bigger, what happens to the fraction? Well, the fraction gets bigger. So I can say that this is bigger than that, which is bigger than this, which is equal to this. The net result is this function right here, x plus 1 over the square root of x to the 4th minus x, is actually greater than 1 over x, for x is bigger than 1. So when I look at the integral from 1 to infinity of this function, that's going to be greater than the integral from 1 to infinity of 1 over x dx. And we know that this one's infinity because we did it, natural log, plug an infinity in. So this one diverges. we found a function less than the one that we wanted, and that smaller function had an integral equal to infinity, and so the bigger function must also do the same thing. Okay? Comparison tests. What function are you comparing to? Sometimes you've got a lot of options. Generally, I try to figure out, like I did here, what's the basic flavor of this thing? As x is getting really big, this thing is behaving like a 1 over x. And I know that the integral of 1 over x diverges as you head towards infinity. So I'm expecting this to diverge. On the previous example, this was a 1 over x squared plus 1. As x is headed to infinity, this is looking like a 1 over x squared, and that one I've already seen. 1 over x squared is good. That one converges. So, so on that one, I was expecting to find, I wanted to find something bigger than it that converged, and so that I could show that this one converged. Right? If you have an idea ahead of time whether you're trying to show convergence or divergence, it tells you whether you're looking for a function bigger or a function smaller. Anyway, comparison tests. Pick a function that's nice to compare to. Generally, 1 over x to the p is probably pretty good. Other examples that are good to compare to are like an integral of e to the minus x from 0 to infinity or something like that, that you know that this one converges. Anyway, you're going to have to try some of these and ask questions about them in the discussions.